In the hyper-competitive world of semiconductor manufacturing, imagine a company generating about $1.4 billion in revenue.
Right, right. A massive operation.
Massive. And they just completely stopped talking to their own marketing department.
Just zero communication.
Exactly. Zero communication between the engineers actually building the silicon and the people analyzing what the global market, actually needs.
Wow.
They were fundamentally building the future blindfolded. And what's most terrifying about that scenario isn't just that it happened.
Right.
It's that structural failures like that are, well, they're remarkably common at the highest levels of corporate R&D.
They really are. I mean, it completely shatters the illusion we often have about, institutional innovation.
Yeah, we think bigger is better.
Exactly. We assume that infinite resources naturally result in this streamlined, logical march toward technological breakthroughs. But when you examine the actual architecture of R&D management, you find a landscape that is just crippled by mid-management bottlenecks.
Oh, absolutely.
And misaligned incentives.
Yeah.
And a chronic inability to connect long-term strategy with daily operations.
Which is exactly why we are dissecting this today. We're speaking directly to you, the prospective PhD student, as you prepare to step into the incredibly nuanced world of R&D management and technology road mapping.
It's a fascinating field.
It really is. And you already know the baseline realities, right? Corporate silos, high capital expenditure, all that. So our objective with this custom deep dive is to push past those basics and really arm you with the specific structural methodologies driving this field.
And to do that, we're drawing heavily from a really foundational text. It's the 2014 Springer publication, Planning and Road Mapping Technological Innovations.
Right.
It was edited by Tugral Udaim, Melinda Pizarro, and Rajasri Talla. And it's foundational because it doesn't just theorize.
It gets into the real world.
Exactly.
Yeah.
Uses rigorous qualitative analysis to deconstruct how these massive organizations attempt and, quite often fail to manage the future.
So our mission for this deep dive is to give you a comparative teardown of the case studies presented in the research. We want to look at the mechanics of their successes and their failures.
The nuts and bolts.
Yeah. And most critically, for your upcoming dissertation, we're going to extract the unexplored gaps in this literature so you can pinpoint exactly where to plant your flag for your PhD research.
I love that. And, well, before we look at the companies themselves, we have to establish the lens the researchers used.
Right, the framework.
Yeah, they anchored their qualitative interviews using the Damon Oliver 6-step framework for technology road mapping.
So walk us through the mechanics of that framework, because, on the surface, road mapping often just looks like corporate buzzwords layered over a giant Gantt chart.
It really can.
How does the Damon Oliver model actually operationalize innovation?
Well, it breaks the chaos of R&D down into a sequential dependency chain.
Okay.
Step 1 is identifying needs and drivers, so the macro market demands. Step 2 is identifying the products or services that specifically satisfy those drivers. Step 3 is identifying the underlying technologies required to actualize those products.
Got it.
Step 4 is establishing the linkages among those first 3 steps. Step 5 is developing the acquisition or development plans for those technologies.
The actual plan.
Exactly. And finally, Step 6 is assigning the human and financial resources to execute those plans.
Okay, let's pressure test that sequence so it really sticks. If we apply this to something incredibly complex, say directing a multi-year space mission to establish a lunar base, right?
Okay, I like where this is going.
Step 1, the driver, is sustaining human life in a vacuum.
Yep.
Step 2, the product, is the modular habitat. Step 3, the technology, means you have to invent a new type of lightweight radiation shielding.
Right, exactly.
Step 4, establishing linkages, means calculating exactly how the weight of that theoretical shielding impacts the thrust requirements of the rocket. Ensuring the tech actually aligns with the physical product constraints.
That is a perfectly accurate mapping of the first 4 steps. You've successfully aligned the macro goal with the technological requirements.
But stepping into the role of a PhD researcher looking at this, my immediate critique is that this feels dangerously like a rigid waterfall project management model.
Ah, yes.
In a modern R&D environment where technology iterates in weeks, not years, doesn't a strictly linear 6-step sequence invite obsolescence before you even reach step 5?
That is a highly valid critique. And honestly, it's a very common friction point in the literature.
I would imagine.
But the authors clarify that while the steps are numbered, the linkages in step 4 actually require a continuous iterative feedback loop.
Oh, okay.
So if the radiation shielding in your analogy proves physically impossible to manufacture, that data immediately flows backward to alter the product design in step 2.
Makes sense.
However, the text highlights that the true institutional paralysis almost never happens in those first 4 steps.
Real.
Yeah. Identifying market needs and mapping theoretical tech is intellectually stimulating. The systemic failure consistently occurs at steps 5 and 6.
Ah, the acquisition plan and the resource allocation. Translating the grand strategy into a literal budget and a hiring mandate?
Precisely.
Yeah.
Step 6 forces abstract strategy to compete with current operational reality for the exact same pool of engineers and capital.
Which is always a bloodbath.
It is. And that tension is the perfect transition into how this framework behaves in the wild. The researchers analyzed 2 vastly different environments to test this: a massive government entity and a private manufacturer.
So let's start with the government side. The text examines the Bonneville Power Administration, or BPA.
Right.
And for context, this is a nonprofit federal agency under the Department of Energy. They manage 31 federal hydro projects and over 15,000 miles of high-voltage transmission lines.
It's massive scale.
Huge. They provide a third of the electric power to the Pacific Northwest. So the stakes are literal total grid stability.
And when you measure BPA against the Damon Oliver framework, their absolute peak performance occurs at step 4, establishing linkages.
Okay.
Because they are maintaining critical infrastructure, they've developed this intense internal culture of alignment. They even use a specific phrase for it: bringing the right rock.
Bringing the right rock.
Yeah, it's a methodology demanding that senior executives, subject matter experts, and national labs achieve total consensus on the strategic priority before a single dollar is allocated to a project.
Well, I have to challenge the efficacy of that. Bringing the right rock sounds like a recipe for institutional paralysis.
It certainly can be.
Because if a researcher needs absolute consensus from every senior executive in a utility company before exploring a new technology, doesn't that inherently kill any genuinely disruptive, out-of-the-box innovation?
Yes.
You're mathematically guaranteeing that only the safest, most incremental research ever gets funded.
The data absolutely supports your conclusion there. Extreme consensus mitigates catastrophic risk, but it inherently sterilizes the R&D pipeline. And the text notes that this culture of extreme caution actually bleeds into their implementation of stage gates.
And stage gates are the checkpoints where management decides to continue or kill a project's funding, right?
Tentatively. It's standard practice. You establish metrics, and if the project fails to meet them, you cut your losses. BPA's internal mantra is literally fail early, fail cheap.
Which is a great mantra.
It is, but their organizational psychology completely subverts it.
How so?
The researchers found that project managers at BPA are often terrified of the professional stigma associated with a failed project.
Oh, wow. So they hide it.
Yes. Instead of adhering to the fail early philosophy, project managers will artificially label a failing, over-budget project as green during a stage gate review.
They're greenwashing their own failures.
Exactly. They massage the data out of fear, which artificially keeps doomed projects on life support. And that drains capital that should be reallocated to viable Step 6 resources.
That is a fascinating psychological bottleneck. They have the architectural framework to kill bad projects, but the human element refuses to pull the lever.
Exactly.
And the text also points out a severe mechanical failure at the end of their pipeline, right? The lack of a formal technology transfer process.
Yes, that's a huge issue for them.
They can successfully research a new grid technology, but they lack the operational mechanism to systematically pull that technology out of the lab and actually integrate it into those 15,000 miles of transmission lines.
Which means the R&D effectively exists in a vacuum.
Oh, yes.
Right. Now, contrast that bureaucratic, consensus-heavy environment with case number 2, Daimler Trucks North America, or DTNA.
Okay, totally different beast.
Completely. We're shifting to a $3 billion private manufacturer operating within a highly competitive, profit-driven global matrix organization.
So does the private sector profit motive actually solve the bureaucracy we saw at BPA?
Well, it solves the technology transfer problem, but it introduces a completely different structural vulnerability.
Of course it does.
Right. So DTNA is incredibly proficient at translating complex research into tangible products. The book highlights their predictive cruise control system.
Oh, I read about this. It's wild.
It is. Instead of just maintaining speed, DTNA integrated GPS, digital terrain mapping, and real-time computational algorithms to adjust engine output based on the topographical gradients a mile ahead of the truck.
So they seamlessly connected a market driver fuel efficiency with advanced software and hardware integration.
Yes, that demonstrates absolute mastery of steps 3 and 4. But you asked about the structural vulnerability.
Right. How does a massive matrix organization like DTNA fail at step 6 resource allocation?
It comes down to how a matrix organization distributes authority. DTNA does not utilize a massive, isolated R&D department.
Okay.
The development of advanced projects relies on pulling shared resources, so engineers and technicians from the daily manufacturing and engineering divisions.
Ah, and there's the friction.
You see it.
Yeah, because the mid-level managers running those daily divisions are judged and compensated based on this quarter's production quotas, not a technology roadmap slated for 5 years from now.
Exactly. The top-level executives are fully aligned on the long-term roadmap, but at the mid-management layer, communication and cooperation completely break down.
They're protecting their turf.
Right. The incentive structures actively punish mid-level managers for releasing their best engineers to work on long-term R&D.
Wow.
Consequently, they hoard their talent to ensure daily operational targets are met. And that starves the strategic roadmap of the human capital required to execute Step 6.
It creates this paradox where the ultimate enemy of the company's future is its own present success.
Beautifully put.
It seems like the shared resource dilemma is the universal gravity pulling down R&D management. Because whether you're a government agency keeping the grid online or a private manufacturer building trucks, operational emergencies will always cannibalize the research budget if the organizational structure permits it.
That tension is arguably the most critical takeaway from the comparative analysis. Managing multiple projects with shared, cross-functional resources is where the Dame and Oliver framework faces its harshest reality check.
Well, if that's what happens when organizations have roadmaps but struggle to execute them, we need to analyze the failure state of an organization that completely abandons the theoretical framework.
Oh, yeah.
The worst-case scenario.
Exactly. This brings us back to the scenario I mentioned at the very beginning, the $1.4 billion public semiconductor company.
The book presents this as the ultimate cautionary tale of the missing map. This semiconductor firm was bifurcated into a high-volume mobile unit and a high-margin network infrastructure unit.
Okay.
And in the semiconductor sector, the sheer physics of shrinking transistors means process technologies require 2 to 3 years of lead time just to develop.
Yet the researchers found this company operated without any 3 to 5 year product roadmaps. How does an engineering firm at that scale even function without a map?
They function entirely through reactive management.
Because they lacked a roadmap, the R&D department focused exclusively on the mobile unit, which was generating the immediate revenue. They abandoned step 1, identifying market needs, because, as you mentioned earlier, they literally severed communication with their own marketing department.
Let's dissect the mechanism of that failure, because it wasn't just a loss of market share. It triggered an internal infrastructure collapse.
They really did.
The text details how their lack of long-term planning forced them into massive technological debt. They were operating their internal systems on legacy mainframe backends coded in outdated languages.
Yes, like COBOL and Natural.
Right. And to understand the severity of that, you have to look at the causality. Upgrading a corporate infrastructure from COBOL to a modern, platform-independent architecture like Java is a multi-year, highly resource-intensive project.
Right.
If your entire organizational philosophy is restricted to surviving the next 6 months, you can never justify a 2-year internal IT overhaul.
Exactly. So the lack of a product roadmap structurally guarantees that you also lack an operational roadmap.
You're just trapped.
You are. You're trapped patching outdated code because you can never pause production long enough to rebuild the foundation. And the longer you operate without a map, the more expensive your baseline operations become, until the tech debt eventually just suffocates the organization.
It's basically management by reaction. Without a roadmap, you aren't an R&D department. You're just a highly paid IT support desk trying to keep the current product alive.
That is a brutal but completely accurate assessment, and it perfectly illustrates why R&D management cannot be segregated from operational IT or human resources. They're fundamentally intertwined.
They really are.
And that complex interdependency is exactly what we need to pivot toward for the final segment of this deep dive.
Yes, let's talk to the listener directly here. As a PhD student absorbing all of these structural failures, how do you translate these industry gaps into a viable original dissertation?
This is the critical mapping of the unexplored frontiers. The source material lays out several distinct avenues. Let's break down the mechanics of how a researcher would actually attack these opportunities.
Lead the way. What's the first frontier?
Opportunity number one explores the cultural impact on risk tolerance within R&D portfolios.
Okay.
The text contrasts the risk matrix of Daimler, operating under a distinctly German corporate culture, against U.S.-based tech giants. A compelling PhD dissertation could design a comparative framework analyzing how geographic and cultural environments dictate the acceptance of black swan risks versus incremental innovation.
Oh, wow. So asking if the Silicon Valley move fast and break things, ethos statistically outperforms the meticulous, stage-gate-heavy European manufacturing model over, say, a 20-year horizon.
Exactly.
That allows for a brilliant blend of organizational psychology and hard quantitative analysis. You aren't just looking at the products, you're quantifying the cultural baseline of the engineers.
Yes, sir.
What's the second opportunity?
Opportunity number two focuses on intellectual property as a divergence point. We saw how BPA, as a public entity, handles technology transfer very differently than a private firm. Researching the divergent IP strategies between public utilities and hyper-competitive private firms offers a massive gap in the literature.
Right.
How do open source or public domain requirements in government-funded R&D fundamentally alter the technology road mapping process compared to an entity like DT&A, which relies heavily on patent protection for its competitive advantage?
A researcher could map the literal speed of innovation between those two models, analyzing if the need to secure IP at every stage gate artificially slows down private sector roadmaps compared to public sector consortiums.
Precisely. It's a very rich area for study.
That is highly viable. What about the third opportunity?
The third is tackling the core bottleneck we identified earlier, the dedicated versus shared resource dilemma.
Ah, the hoarding issue.
Yes, this is the holy grail of R&D organizational structure. The literature suggests investigating a divide-and-conquer approach.
Meaning, does creating a completely isolated, dedicated R&D team solve the resource hoarding problem we saw at DT&A?
Exactly. But a PhD researcher needs to test the counter-hypothesis too.
Which is?
If you isolate R&D from the daily manufacturing engineers, do you inadvertently create a team that designs theoretically perfect products that the factory floor literally cannot build?
Oh, right, because they're too disconnected from reality.
Yes. Your research could analyze the exact structural tipping point where the benefits of a dedicated R&D team are outweighed by the loss of cross-functional operational reality.
You would be measuring the exact cost of a silo.
Exactly.
That's brilliant. And that leads directly into the fourth opportunity, right? The
Yeah.
one dealing with mapping the actual humans doing the work.
Yes.
The text introduces the design structure matrix, or DSM, utilizing a case study of a Chinese software company called DataSheen. Explain the underlying mechanism of DSM because it sounds like a profound way to quantify corporate communication.
DSM is a fascinating analytical tool. At its core, it's an n-by-n square matrix that models the dependencies of a complex system.
Okay.
Traditionally, it maps tasks. So if task B cannot start until task A finishes, you map that dependency. But the DataSheen case study applies DSM to the virtual social network of the engineers themselves.
So instead of mapping the code required to build their CRM platform, they map the flow of information between the developers writing the code.
Precisely. By visualizing the human network in a matrix, researchers can identify exactly where information bottlenecks occur. They can mathematically cluster groups of engineers to eliminate redundant communication loops in globally dispersed teams.
That's incredible.
Right. A PhD dissertation expanding on DSM to optimize human resource allocation during step 6 of the Damon-Oliver framework would be a massive contribution to the field of engineering management.
Okay, so if I'm sitting across from you as a first-year PhD student, looking at those 4 distinct paths, we have cultural risk mapping, public-private IP divergence, the shared resource dilemma, and DSM communication mapping.
Yep.
Where do you advise I focus my energy? Which of these represents the most urgent, unsolved crisis in the industry right now?
Without hesitation, the most urgent crisis is the multi-project resource allocation dilemma. The friction between shared and dedicated resources.
Really? That's the one.
Absolutely. Because you can design a flawless Damon-Oliver framework, and you can map the perfect virtual social network using DSM. But if the incentive structures of your mid-level managers encourage them to hoard talent, the roadmap is useless.
It's dead on arrival.
Exactly. The most profound technological failures we analyzed didn't occur because the engineering was flawed. They occurred because human psychology and misaligned corporate incentives block the engineers from doing the work.
Yeah.
Solving that structural paradox is the most valuable research you could conduct.
That perfectly synthesizes the complexity of the landscape we've explored today. We have torn down the Damon Oliver framework, demonstrating that while steps 1 through 4 are vital for aligning market needs with theoretical tech, the true gauntlet is steps 5 and 6.
Yes. We analyzed how BPA's culture of consensus paralyzes their risk tolerance, resulting in project managers greenwashing failing research.
Right, and we examined DTNA's matrix organization, where long-term strategic brilliance is just suffocated by mid-management resource hoarding.
We look at the terrifying reality of the semiconductor firm operating completely blind, proving that without a roadmap, a billion-dollar company rapidly devolves into an IT support desk, drowning in COBOL technical debt.
It's a bleak picture, but a necessary one. And we have armed you, the listener, with 4 highly specific, rigorously backed avenues for your dissertation.
You now possess a comprehensive structural map of the current literature, but as you transition from absorbing this deep dive into drafting your own research proposals, I want to leave you with a fundamental challenge to the entire discipline of technology road mapping.
Oh, okay. Introduce the friction. What is the blind spot here?
Well, every framework we've discussed today, including Damon Oliver, relies on an inherent assumption. It assumes that we are road mapping technologies whose trajectories we can reasonably extrapolate based on current market drivers.
Right, things we can somewhat predict.
Exactly. But as you enter your PhD, ask yourself this: how does a highly structured, inherently rigid methodology prepare an organization for black swan events?
Oh, wow.
How do you apply a 6-step dependency chain to disruptive combinatorial technologies that completely rewrite the underlying physics or economics of your industry in a matter of months? Can a formal technology roadmap ever truly insulate a company against an invention it lacks the vocabulary to even conceptualize?
That is heavy. If the framework requires a known destination, what happens when the map itself becomes obsolete overnight?
Exactly.
That is the structural paradox you will be wrestling with for the next few years.
Thank you for joining us on this deep dive. We wish you immense clarity, rigorous data, and profound success on your upcoming PhD journey.